Economics education has a chronic mechanical problem. Universities rely heavily on a passive, lecture-based transmission model, where the instructor delivers abstract theoretical concepts and the students record them. The gears of instruction turn, but they often fail to connect with the student's driveshaft, resulting in a failure to translate theory into momentum. To solve this, institutions have increasingly turned to a specific structural intervention, the flipped classroom. The mechanics move foundational content delivery out of the lecture hall and into pre-class materials, usually video, to reserve in-class time for active, collaborative problem-solving. This structural shift is rooted in the social constructivism of Lev Vygotsky. He argued that meaningful learning is not a solo endeavor, it requires social interaction. In this model, students construct knowledge through collaboration rather than passively receiving it in isolation. Recently, researchers at University Sultan Zainal Abidin put this theory to a rigorous test within their agricultural economics curriculum. They monitored 92 undergraduates to see what happens when the traditional lecture is dismantled and replaced with a flipped pedagogy. Intrigued, their findings created a fascinating paradox. The study proved that the flipped classroom successfully engineered overwhelmingly positive student engagement. The students valued the flexibility and the interaction. Yet, when the researchers measured actual academic performance, the outcomes between the flipped and traditional groups were statistically indistinguishable. A flat grade curve following a highly engaging teaching intervention provides a critical diagnostic insight. It reveals a hidden latency between a student's enthusiasm for a new method and their ability to master the material through it. To understand why grades stalled, we must examine the study's sound quasi-experimental methodology. They established a baseline control, Group 0, of 37 students taught through conventional lectures. This was compared against a treatment group of 75 students using the flipped classroom model. The variables were tightly controlled. Both groups were taught by the same instructor, covered an identical syllabus, and took exams matched exactly to the same course learning outcomes. Because the assessment variables were perfectly matched, the testing environment was fair. Any anomalies in the outcome data were likely a direct result of how the students interacted with the instructional method itself. Let's look at the qualitative data first. In Table 2, 95% of students agreed that pausing and rewinding video lectures helped them learn, actively managing their own cognitive load. Furthermore, discussing with classmates achieved near-universal agreement, validating the social aspect of the intervention. These results align with self-determination theory, which suggests that motivation is driven by three basic psychological needs: autonomy, competence, and relatedness. By providing self-paced videos for autonomy and peer discussion for relatedness, the flipped model successfully met the students' psychological requirements for engagement, and the students actually did the work. 80% of them reported regular compliance with the pre-class video requirements, ensuring the foundational knowledge was at least delivered. By every qualitative metric, the flipped classroom functioned exactly as designed. It successfully drove their active behavioral engagement. But behavioral engagement is not the same as academic mastery. Table 3 displays the independent samples t-test comparing the final academic performance of the two groups. This maps the distribution of final scores. Traditional achieved 66.62, and flipped scored 66.99. The curves overlap entirely. A p-value of 0.82, far above the 0.05 threshold, and a confidence interval crossing 0 indicate these results are statistically identical, indistinguishable from random noise. This is the central mystery. Educators built an interactive system students loved, yet it did not improve their written mastery of agricultural economics on paper. To understand why the grades stalled, we must look closely at the course architecture. Table 1 lists the week-by-week syllabus. Notice the implementation timeline. The flipped methodology was applied to only 5 or 6 topics out of a 14-week semester. The intervention was inherently short-term. This reveals the first failure point, the readiness gap. Normally, a student watches the video and enters active problem-solving. But if students skip this pre-work, the instructor must spend class time reteaching basic definitions, collapsing the active session back into a remedial lecture. This gap disproportionately harms weaker students. If they arrive without the foundational concepts, They fall further behind during high-level collaborative tasks, widening the disparity between them and top performers. There is also a second, deeper failure point at play, the adaptation penalty. Students enter the university system with over a decade of ingrained habits. They are trained to take passive notes. Transitioning into a self-directed learner who actively constructs knowledge is a heavy cognitive lift that takes much longer than 5 weeks. Rather than a failure of the method, this null result demonstrates pedagogical infrastructure takes much longer to mature in a student's brain than mere enthusiasm. Based on these findings, we can visualize how educational interventions actually scale. This graph tracks 2 different rates of impact over time. Student engagement is highly reactive. When you introduce autonomy and peer collaboration, psychological needs are fulfilled almost immediately. The engagement spikes within the first few weeks. Academic performance is structurally inelastic. Because of the adaptation penalty, the performance curve flatlines through that same initial period, while students learn how to learn. Translating early engagement into measurable grade improvement requires continuous, multi-semester implementation. It is only after these self-directed habits formalize that the performance curve finally bends upward to meet the engagement trend. When viewed through this lens, a p-value of 0.82 after a partial semester is not a disappointing result. It is a predictable phase of pedagogical evolution. This study dismantles the myth that simply uploading recorded lectures automatically generates higher achievement. Success requires structural accountability. If you do not formally assess pre-class preparation, the flipped architecture will buckle under the weight of unprepared students. For administrators, the lesson is clear. Positive end-of-semester course evaluations indicate healthy engagement, but they do not guarantee increased academic results without allowing adequate time for cognitive adaptation. Do not abandon active learning methodologies just because the first set of grades remains flat. Achieving measurable improvements in learning outcomes requires institutions and educators to hold their nerve and have the patience to outlast the adaptation penalty.